All right, folks. Welcome to the review of all things AP microeconomics. As a reminder, this is just a brief overview. I'm not going to get into too much specifics. If you think you need to get a little bit more of a refresher, go back and check my other videos or practice worksheets and things like that to really dig into the material. This is just supposed to be a reminder. So keep that in mind. And let's get started with our first unit, Econ Basics. So the most basic thing to remember is the idea that scarcity exists. So scarcity just means that you can't have everything you want. Things are limited, and that's the basic problem of economics. Resources are scarce. You should say scarce, not scare. Resources are scarce, and human wants are unlimited. So this is why we make choices, and that's why economics is really all about making choices. How do we make choices in economics? Everything is marginal analysis. So if you see that on the AP test, see marginal thinking or anything like that, it's always the idea of the cost of doing something a little bit more versus the benefit of doing it. And in every case, you are going to make the decision that your benefit should always outweigh your cost. And at the point when they're equal, that's when you stop whatever you're doing. And this is partially because of something called opportunity cost. Opportunity cost is the value of what you could have done with your resource. So it's the value of your second choice option. So if I have $1 and I spend it on a candy bar, that candy bar's opportunity cost isn't $1. It is what I could have done with that dollar otherwise. So maybe I would have bought a bag of chips. So my opportunity cost for buying the candy bar is the bag of chips. This plays into economy-wide a production possibilities curve. So this is a straight or bowed out line that shows the maximum quantity of goods that an economy can produce. Yes, it's simplified. In this economy, you can only produce two goods. So if in this example you see guns on the left on the y-axis, butter on the x, if you are all the way on the y-axis, this economy is producing 30 units of guns and 0 butter. Or if they decide to switch to all butter, the opportunity cost is 30 guns and the benefit is 30 butter. Um, when you're looking at a PPC, remember efficiency points. It's efficient anywhere along the curve. It is inefficient anywhere under the curve. So if I put a point here and label it point B, that's inefficient. If I put a point here and label it A, that is efficient. And if I put a point up here and label it C, that can't occur yet. You need economic growth for that. Economic growth exists when you have a sustained change to one of the factors of production. There is a slight chance that they might give you something about capital goods versus consumer goods, which will yield more economic growth. Capital goods yields more economic growth. So if you had 2 points along this curve, A and D, instead of guns, this was capital, and instead of butter, this was consumer. D would yield more economic growth than A. I doubt that'll show up. That's more of a macro principle. But economic growth in general does show up if there's a sustained increase to one of the factors of production. Also, remember increasing versus constant opportunity costs. What we have here is an example of constant opportunity costs. As you move along the curve, they will give up a constant amount of whichever way you're moving. So if you're moving down and to the right, you're giving up a constant amount of capital goods, now that I've changed the labels. Or if you're moving up and to the left, you're giving up a constant amount of consumer goods. If it's bowed outwards, so if it looks like that red line I just drew, then that's increasing opportunity cost. So that means as you move along the curve, you're giving up more of whatever you're giving up. This relates heavily into the idea of comparative versus absolute advantage. So now we are examining two different economies. So if an economy has an absolute advantage, that just means that they can produce more of a given product. I can produce 10 units of good A, you can produce 5. I have the absolute advantage. That doesn't necessarily mean that I will specialize in that product. Instead, you specialize based off of comparative advantage. This just means that you have a lower opportunity cost, and you can't have comparative advantage in both goods. Now, to find who has the comparative advantage, finding those opportunity costs, you have to first look at what type of problem it is. Is it an input or an output problem? If it's an output problem, this is more common. This is when it tells you the specific output. So if country A is producing computers, that is an output. If it says it takes Jimmy 2 hours to produce a computer, that is an input problem because it's giving you the time. That's an input. So when you're handling output problems, remember O for output means that other, that's the second O, goes over. That's the third O. Other goes over for output. So what we mean by that is the opportunity cost equals what the economy is giving up, that's the other, divided by what the economy is producing. So those are the maximums. So what it's giving up, maximum of that, versus what it's producing on the denominator. For inputs, it's flipped. And the way you remember this is IOU. I for input uh, means other goes under. O is the O, under is the U. So opportunity cost equals what the economy is producing, maximum, divided by what the economy is giving up, the other. Once you figure out the opportunity cost, you choose whoever specializes in it based off who has the lower opportunity cost. That's their comparative advantage. That's what they specialize in. In order to find out the terms of trade, which is fairly uncommon for microeconomics tests, but might show up, all you have to do is find the terms of trade that falls between the opportunity costs. So if the opportunity cost is 1 for country A and 1/2 for country B, then one of good A being sold for 3/4 of good B, that fits within those terms of trade. Second unit, supply and demand. Demand is just how much people on a whole are willing to buy or buy, willing to and able to buy at different prices. So basically, every individual has a demand curve. You add them together, and that becomes the demand curve for the market. The law of demand says that as price rises, quantity falls. That's movement along the curve, and it's important to remember movement along the curve. That is different from shift of the curve. If you see demand changed, that implies the whole curve shifted. If you said price changed, that is movement along the curve. The demand curve itself is downward sloping. This is caused by the substitution effect. This is the idea that as one good becomes more expensive, you're more likely to substitute it out for something else. It's also caused by the income effect, which basically says that as one product becomes more expensive, it's eating up um, uh, more of your money. So you are less able to purchase it and other goods, so you buy less of it. Income effect doesn't show up a whole lot. Substitution effect definitely does. The third way that it's downward sloping is due to diminishing marginal utility, which says that as you consume more of a good, the utility or satisfaction you get from consuming that good decreases. So you'd be willing to pay less per unit as you buy more. That's the reason why extra large sodas cost marginally less than a small soda. So you spend $1 on a small soda, you spend $1.25 to get the extra large. That doesn't make sense when the extra large is 3 times as big. It's because of that diminishing marginal utility. Factors that shift demand. Now this is moving the entire curve left or right. Left decreases, right increases. Changes in prices of related goods. This one's fairly common to show up if there is a substitute good that has a price change. So this is something that you use in place of your original goods. So pens and pencils is probably the most easiest one to remember. So there is a direct relationship here. So if the price rises of pens, I'm more likely to purchase pencils. Demand for pencils rises. Complements, these are things that go together. So think peanut butter and jelly. They go together. You buy peanut butter, you buy jelly to use with the peanut butter. These have an inverse relationship. So as price rises of peanut butter, I'm less likely to purchase jelly, so my demand for jelly decreases. Changes in income. This depends on the type of good that you're looking at. If it's a normal good, they have a direct relationship. More income means you buy more of it, means your demand increased. If it's an inferior good, these are things like generic brand things. So generic brand cereal, if you will. If I have more income, I'm more likely to buy the name brand. I'm less likely to buy the generic brand. My demand decreases. So there's an inverse relationship there. Changes in taste. So if there's a fad, for some reason, people really like silly bands again, demand for silly bands increases. Changes in expectations. If you expect the price to rise in the future, you're going to want to purchase it now, so demand rises now. Um, if you expect the price to fall in the future, you're not going to purchase now, demand falls now. Changes in number of consumers. So if the population explodes for some reason, then there's going to be more people to purchase the good, demand increases. On the supply end of things, this is the upward sloping curve. That is the law of supply. They are positive, price and quantity are positively related. This is caused by the basic idea of the price effect, which is just the idea that as price increases, you sell each of these goods at a higher price, therefore revenue increases. Now, what causes the supply curve to shift? Once again, left shift is a decrease, right shift is an increase. Changes in input prices is a pretty common one. So basically, if your workers cost more, if you have to pay them more, then you are less able to produce, your supply shifts left. So input prices rises, supply shifts left. Input prices fall, supply shifts right. Changes in prices of related goods or services. These use the same terms as uh, the ones we used for demand, but they will always say in production afterwards. So substitutes in production, these are things that one firm can make with the same raw materials. So you can think a 2x4 or a baseball bat, those are substitutes in production. You make one or the other. These have an inverse relationship. So if the price of a substitute in production rises, price of baseball bats rises, supply of 2x4s falls. Complements in production, these are things that are produced by a byproduct. They're a byproduct of whatever you're producing. So when you're making something made out of wood, like a baseball bat, you also produce sawdust as a byproduct. Uh, this has a direct relationship. So if price of baseball bats rose, I'm going to make more baseball bats. Therefore, uh, supply of sawdust will increase. Changes in technology. This one's fairly easy to understand. You have better technology, supply increases. Um, if for some reason all of your technology is destroyed, supply decreases. Changes in expectations. This is going to have the opposite effect for producers that it did for consumers on demand. So for producers, if they expect the price to rise in the future, they're going to decrease supply now because they will want to sell more in the future. If they expect price to fall in the future, they're going to supply more now if they're able, so supply will increase. Changes in number of producers. This one shows up most frequently when we're talking about perfect competition and monopolistic competition in market structures. Uh, if there's an increase in number of producers, supply increases. If there's a decrease in number of producers, supply decreases. Once you put those two curves together, you get something called equilibrium. Equilibrium is your market clearing price. It's the happy place for the market. It's where the market wants to be. This is going to be totally efficient, at least in competitive markets. Once again, this is assuming no externalities. This is sort of symbolized by the fact that your total surplus is maximized here. Now, a little bit more with that total surplus, you could split that up into consumer and producer surplus. If you take the equilibrium price as a dividing line, that gives you your consumer and producer surplus triangles, as you see illustrated on this graph here. You can always find consumer and producer surpluses by finding the area of the geometric shape. In most cases, it will be a triangle of the quantity, the price consumers pay, the y-axis, and the demand curve. That will always get you your consumer surplus. Notice the way I phrased the price consumers pay there, as when we do taxes and when we do different things that manipulate the market, you'll see that the price consumers pay will be different from the equilibrium price and might be different from the price producers receive. Now onto producer surplus. It's always the area of the quantity sold, the price producers receive, y-axis, and the supply curve. So this triangle is the producer surplus. In order to get total surplus, you just add those two together. Now, what if the price is not at equilibrium for some reason? Either a surplus or a shortage will occur. So if you have a price set above equilibrium, there will be a surplus. And essentially what's going to happen is your quantity supplied will be greater than your quantity demanded. The amount sold will be on the whatever curve it hits first. So if there's a surplus, let's say the price is at 4, it hits demand first. It will sell that quantity, but there will be a surplus, which will be the difference between the quantity demanded and the quantity supplied. So what will happen is market forces will cause that firm to lower its prices to get rid of the surplus, decreasing the space in between quantity demanded and quantity supplied until you reach equilibrium. If it's at below equilibrium price, what you're going to have is a shortage because you're going to have a lower quantity supplied and a higher quantity demanded. The difference between them, once again, is going to get you your quantity of surplus and market forces, if they're allowed to occur, assuming that there is no price ceiling or price floor that would stop the market forces from occurring. You're going to get the price rising until you eliminate the shortage. Now, once you get your equilibrium price and quantity, you can get shifts. If demand shifts on its own, demand shifts right, your price and quantity will rise with it. If demand falls, price and quantity both fall. If supply rises, price falls, quantity increases. If supply decreases, the opposite occurs. That one's pretty easy. If you can't remember those, which it's easy to forget, just draw a quick sketch out on your scratch paper. It should be pretty easy for you to do. Where it really gets in trouble is when you have double shifts. For this, you just have to look at the effects of each of the shifts individually. So for the first one here, demand decreases and supply decreases. What are their effects on price? Well, when demand decreases, we're looking at this one right here, price decreases. When supply decreases, price increases. They have opposing effects, so we don't know what happens to price. What about their effects on quantity? Well, when demand decreases, quantity decreases. When supply decreases, quantity decreases. Therefore, we know quantity will always decrease when they both decrease. If the opposite occurs, and we're looking at demand increasing, supply increasing, we don't know what happens with price, but the opposite effect will happen with quantity. If demand decreases and supply increases, so we're now looking at this one again, and now we're looking at this one. Their effects on price are now the same. Price decreases for both. But their effects on quantity are different. Quantity increases when supply increases, and quantity decreases when demand decreases. So we don't know what happens to quantity. And when we look at the last one, you'll see that the opposite occurs. So it's always best to take a look at that like that. Look at it individually to try to understand. Now, of course, if they give you an actual graph that shows you the shifts, then you can find out if price or quantity increased or decreased based on the actual graph they give you. But they just describe it. You have to be able to be okay with the idea that you might not know what happens to equilibrium price and quantity depending on the shifts. If there is a price ceiling, an effective price ceiling is set below equilibrium because it's saying that the price is not allowed to go above this point. If a price ceiling is put above equilibrium, then market forces will keep that price just at equilibrium because that's where the market wants to be. So if there's an effective price ceiling, it's set below equilibrium, like you see on this graph here, a shortage will be caused. There is a greater quantity demanded, as you see here, than quantity supplied, as you see here. You can once again find the amount of the shortage by just doing quantity demanded minus quantity supplied. The amount sold is the quantity supplied, since that's the first curve it hits, they're not producing the amount of quantity demanded. And what happens if you remove this price ceiling? Then the price will eventually just go up back to equilibrium. Price floor, when this is set, it's an effective price floor is set above equilibrium because this is saying that the price cannot go below the price floor. If a price floor is set below equilibrium, market forces will just keep it at the equilibrium price since that's where the market wants to be anyway. So you find in this case that there is going to be a surplus cost because there is a greater quantity supplied, see here, than quantity demanded. Difference between the two gets you your quantity of the surplus. Now, it is important to note that both price floor and price ceiling cause deadweight loss. This is an inefficiency. Deadweight loss is always the area encompassed by the triangle of the quantity, the supply curve, and the demand curve. So that is the deadweight loss. Now you see the producer surplus here is not a triangle, and this is, but the way you find it is the same way that I already told you. You have your price producers receive, the quantity, the supply curve, and the y-axis. So the producer surplus is there. The consumer surplus, price consumers pay, y-axis, demand, and the quantity purchased. So in this case, you see the consumer surplus shrank, producer surplus, in most cases, is going to grow. A price floor is to help out producers. Let's take that back to the price ceiling and do the same sort of analysis. In this case, we see the deadweight loss in the triangle of the quantity, the supply curve, and the demand curve. So that's deadweight loss. We see the producer surplus and the quantity the price producers receive, the y-axis and the supply curve. So here we see the producer surplus decreased. The consumer surplus is going to be the quantity, the price consumers pay, the y-axis, the demand curve. Our consumer surplus in this case grew. So this is a good illustration of a price ceiling. An effective price ceiling is meant to help out consumers. Quantity controls are when instead of restricting price, you restrict quantity. So you'll see this referred to as a quota. Sometimes you'll see it as licenses are sold, things like that. Liquor licenses is probably the most common one that we see today. And up until Uber and Lyft, really taxi medallions were a great example of quantity controls. This is when you have some sort of behavior that you're trying to limit for some reason. So in this case, we have our supply and demand graph. We have our equilibrium quantity right here. We have our equilibrium price right here. And we have our quota set right here at QC. In this case, there is now a wedge between the price consumers pay and the price producers receive. So the price consumers pay is that quantity on the demand curve, represented here by CC. The price producers receive is that quantity on the supply curve, set here by PC. The difference between the price consumers pay and the price producers receive is what's known as the quota rent. It's the price that is that producers must pay for the taxi medallion or for the liquor license. It's the sort of price they have to pay to do the business. In this case, we do have a sizable deadweight loss. Once again, you find it by the quantity, supply curve, demand curve. So B here is the deadweight loss. And this area A that you see here, this is sort of the total amount of revenue from those licenses that goes to whatever licensing agency there is. So this whole area in here is not going to be profit. It's not going to be surplus. It's revenue to whatever the licensing agency is. Consumer surplus, the quantity, the price consumers pay, y-axis demand curve. Our consumer surplus shrank. Producer surplus, quantity, price producers receive, y-axis supply curve. Our producer surplus also shrank, so our total surplus shrank. Elasticity, efficiency, and utility, unit 3. So this is sort of all things that relate to the demand curve for the most part. Efficiency gets a little bit more detail from that. But the rest are otherwise about the demand curve. The big part of this is elasticity. So this really, in its most basic sense, is uh, how much the quantity demanded responds to a change in price as you move along the demand curve. This is all in percent changes. That's an important thing to remember, especially when you're getting into the calculations of it. A large percent change indicates it is relatively elastic. A small percent change uh, indicates that it's relatively inelastic. There's two effects on total revenue of a price change. The price effect, which is essentially the idea that as you uh, increase the price, each good sells at a higher price, which increases total revenue, since total revenue is just price times quantity. Uh, the quantity effect is the other half of that. The idea that thinking about the demand curve, as the price increases, you sell less of a good, therefore that decreases total revenue. And so elasticity of demand is really about balancing these two effects. So if there is a large change, which of these effects is um, more in charge, and if there's a small change, which of these effects is more in charge. If you want to test the general elasticity of a downward sloping curve in terms of does it tend to be more inelastic or more inelastic, you can use these four tests. The first test is, are there many substitutes? If there are many substitutes, the demand curve is going to be more likely more elastic. You can substitute more things in for it. In the graphs that you see here, insulin has no close substitutes. Therefore, you have a completely vertical line. It is perfectly inelastic. If you can substitute everything for the good, it would be perfectly elastic, which would be a horizontal line, a horizontal demand curve. In most cases, you will have a downward sloping curve, and it's just the level of the slope. A um, if it is a low slope, in closer to a horizontal line, it is going to be more relatively elastic. If it's a harsher slope, it is going to be more relatively inelastic. So closer to a horizontal line, more substitutes. Closer to a vertical line, less substitutes. The second test, uh, is it a necessity? If it is a necessity, you have to purchase it. It's going to be closer to an inelastic demand curve. Uh, if it's a luxury, it'll be closer to an elastic demand curve. Is it expensive? If it's more relatively expensive, it'll be more elastic. Less expensive, inelastic. And time to make the purchase, if you have a lot of time, it tends to be more elastic. Less time, more inelastic. Now, you might be tasked with finding elasticity along the demand curve. Uh, the first method, the one that's most common, especially on multiple choice questions, is the total revenue test. So for this, you just find total revenue, so price times quantity, and how that relates to the change in price. So how did the total revenue change versus the change in price? If they both move in the same direction, if they're positively related, if price increases and total revenue increases, then it is inelastic. If it is elastic, they have a negative relationship there. As price increases, total revenue decreases. And if there's a price change and no change in total revenue, then that is unit elastic. If you are tasked with finding the coefficient of elasticity or calculating elasticity, what it's looking for is you to use this equation. It's essentially you finding the percent change of quantity divided by the percent change in price. And you find that by um, change in quantity divided by the initial quantity multiplied by 100. You can really take out the multiply by 100 in both of these, and then do the same thing to price um, on the denominator. Uh, if it gives you the percent changes, and if it's talking in a multiple choice question, it might give you the percent changes already. It might say the percent change in quantity changed by 10%, price changed by 20%. Is it elastic or inelastic? Well, you just do the percent change in quantity divided by the percent change in price. It's that easy for that one. Now, when we interpret elasticity, uh, you really find a number uh, either greater than or less than 1, because we always drop the negative. So If it is greater than 1, if the coefficient is greater than 1, it is elastic. If it's less than 1, it's inelastic, and it's equal to 1, then it is unit elastic. Now, what does this look like along the demand curve? Because there's an elastic portion, there's a unit elastic portion, and there's an inelastic portion to every downward sloping demand curve. If it is in the upper left-hand portion, it tends to be more elastic. If it's in the middle, it tends to be more unit elastic. And if it's on the bottom right-hand side, that tends to be inelastic. And what this really relates to is the marginal revenue curve, because the marginal revenue curve being positive indicates that as you drop your uh, price, the total revenue will still rise. That demonstrates an elastic curve. So if we consider this the demand curve, and we consider a marginal revenue curve below it, the marginal revenue curve will be shaped something like that. And if you notice, where marginal revenue hits 0, that is the unit elastic portion. Everything above it, elastic, everything below it, inelastic. So as price falls, total revenue will continue to increase because marginal revenue is positive. Uh, Once marginal revenue becomes negative, as you drop the price, the total revenue should fall. There are a few other types of elasticity. The most common one is going to be cross price elasticity. This is the percent change in quantity demanded of good A versus the percent change in price of good B. This just lets you know if there is a substitute or a complement at play here. If the number you get out of this is positive, then it is a substitute. If it's negative, it's a complement. Second most common one that you'll see is income elasticity. So this is percent change in quantity demanded divided by the percent change in income. And this lets you know if it's a normal or an inferior good. If it's positive, it's normal good, negative, and inferior good. The last type of elasticity that you have to know is price elasticity of supply. Find it in the same exact way that you do with demand, only you use supply. So you still have a vertical supply curve that's perfectly inelastic, a horizontal supply curve that's perfectly elastic. Um, and what that essentially means is if it's more inelastic, inputs are fixed or few in number, and it is a short term choice. If you have an elastic or more relatively elastic, then inputs are very available, and you have long term choices to respond to price changes. Now, when we talk about efficiency, we're talking a lot about taxes. So when we have a tax, we're really going to have to know this graph. And what you most commonly see, or what you definitely will see on the AP test, will be a second supply curve right there like this. So if you're asked to graph a tax, you're really drawing two supply curves. You have your first one here and the second one to the left, a negative shift of supply. So what this really does is it creates certain amounts of inefficiency. As your surpluses, both consumer and producer, both decrease, you create deadweight loss and you create revenue for the government. That's where those surpluses go. So how do you find all this stuff and what does this all mean? Well, let's start with our deadweight loss. It's always found about the new quantity sold, the supply curve, and the demand curve. So this gray area, that is our deadweight loss. Let's now find our consumer surplus. It is the quantity, the price consumers pay, with the y-axis and the demand curve. So this area A is the consumer surplus. It used to be the equilibrium price at the equilibrium quantity, the y-axis, the demand curve. So you can see clearly that the consumer surplus shrank. The producer surplus, the flip side of that, the quantity, the price producers receive, the y-axis, the supply curve. This area labeled D is the producer surplus. Once again, it shrank. It used to be at the equilibrium quantity, the equilibrium price, the y-axis, and the supply curve. So it definitely shrank. It shrank by the areas of C and F, just like the consumer surplus shrank by the areas of B and E. Now, let's take a look at the tax revenue and who bears the burden of the tax. So for a tax, you have your per unit amount, which is the price consumers pay minus the price producers receive. The difference between those two is the per unit amount of the tax. To get it down to the burden of the tax, who pays more, you can find it in terms of per unit by using your equilibrium price, your original equilibrium price, as your dividing line. If the difference between PD and your equilibrium price is greater than your equilibrium price minus your price producers receive, then your consumers bear more of the burden. If it's the opposite, then your producers bear more of the burden. And really, this has a lot to do with elasticity. If demand is more inelastic than supply, then consumers bear the burden. If supply is more inelastic than demand, then producers bear more of the burden. You can get the whole tax incidence, in other words, what revenue to the government is being paid entirely by consumers by once again using that equilibrium point as the dividing line, the quantity, and the price consumers pay. So area B is the tax incidence of consumers or the revenue paid to the government from consumers. Producers, it's the area labeled C here, the original equilibrium, y-axis, price producers receive, and the quantity, so C. Your total revenue to the government is B plus C, that entire area. Now, when consumers are making a choice of how much to purchase, they do have to think about their marginal utility per dollar spent on a good. So utility is your satisfaction from consuming a good. So your marginal utility is you consume one more unit of the good. What is your additional satisfaction from consuming that? So you take that and you compare it to how much you spent on that extra unit of the good. Uh, if you only have one good that you're purchasing, uh, and it's within your budget, it's your marginal utility per dollar has to be equal to 1. So mu divided by p has to be equal to 1. They have to be equal to each other, which makes sense when we go back to our marginal analysis that we already talked about. Your marginal utility is your marginal benefit. Your marginal cost is the price you're paying for the good. When they are equal, that is your optimal consumption when you're consuming one good. If you're consuming multiple goods, which is a more frequent question on the AP test, how do you find out how much to purchase? Well, for this case, your marginal utility per dollar has to be equal for all goods, not equal to one, equal to each other, because now you are trying to balance it in terms of your uh, purchasing power and your abilities. Remember, diminishing marginal utility. So as you consume more of the good, marginal utility falls. So if you want to decrease your marginal utility per dollar, you increase consumption. And remember to keep everything within budget. Firm costs. This is a very important unit, unit 4. These are all the firm costs and revenues that you have to keep in mind. Fixed costs, this one comes up very frequently because fixed costs don't change. It's kind of a trick for people because it's always the same and it exists at zero. So if you shut down in the short run, fixed costs still exist. Average fixed costs, which is another favorite question of the AP test, they are always going to be decreasing because it's fixed cost divided by quantity. Whenever you see the word average, it is always the total divided by the quantity. So in this case, it's total fixed cost divided by quantity gets you your average fixed cost. Total variable costs, these are the costs that are associated with variable inputs, just as fixed costs were the costs associated with fixed inputs, which tend to be things like your mortgage or rent or things like that that aren't going to change in the short run. Variable costs can change in the short run because they are associated with variable inputs like labor that can change in the short run. So these will be continually increasing. And you have your AVC, which is your total variable cost divided by your quantity. Your total cost equals your fixed cost plus your total variable cost because it's just your total cost. It's all everything added together. Um, and your ATC is your total cost divided by the quantity, or you could do your AVC plus your AFC. It'll equal out to the same thing. Your marginal cost is the difference from one total cost to the next as you increase your output. Um, you could also find it by the difference in your total variable cost, once again, as you increase your output. Your total revenue is just your price times quantity. That's the amount of money that you are bringing in. Don't confuse it with profit, which is your total revenue minus your total cost. Your marginal revenue is the difference in your total revenue. Your marginal revenue will equal 0 when your total revenue is maximized. That comes up in the AP test a lot as well. Also remember that your marginal cost should equal ATC and AVC at their respective lowest points, and make sure you know why all the costs are shaped the way they are. If you need a refresher on that, go back and look at the guides for each of the cost curves and revenue curves that I put together, and they're up on the Google Classroom. We then get into the idea of economies of scale. This has to do with our long run ATC. Long run ATC is just, it sounds more complicated than it is. It's an approximation of the different levels of your fixed costs. So in the long run, you can change your fixed costs. So imagine you're moving to a larger factory. Each of these short run ATCs that you see outlined here, so you see ATC 3, that's the smallest factory, ATC 6, medium factory, ATC 9, largest factory. Your long run ATC is just approximation of all of those. So what we use this for is really an analysis of what level of fixed cost should we have, and are we experiencing economies of scale or diseconomies of scale? So in other words, is expansion helping our efficiency or is it not? If it is helping our efficiency, then we're experiencing economies of scale. So our LRATC is falling as the firm expands. So this is things like buying in bulk, um, uh, uh, and mass producing things becomes cheaper as you produce more of the good. So that's economies of scale. So your output is rising faster than your cost. Diseconomies of scale is the opposite. Now our output is rising more slowly than our costs, and our LRATC is increasing as the firm expands. So now we are no longer seeing efficiencies from expansion. And this is caused by more difficulties in communication and things like that. Sometimes you'll see economies and diseconomies of scale referred to as returns to scale. So if you have increasing returns to scale, and it doesn't exactly mean this, but for our purposes, the questions run exactly the same. Increasing returns to scale is the same as economies of scale. Your LRATC will be decreasing. If there's constant returns to scale, it's the flat portion of the LRATC. And if there's decreasing returns to the scale, it is the upward sloping portion of our LRATC. When we talk about profit maximization, we look where your marginal cost curve, which once again, this is our decision-making process where our marginal cost curve is equal to our marginal revenue curve. Marginal revenue is the marginal benefit. Marginal cost is obviously the marginal cost. Where those two equal, that is the quantity that firms will produce. So it's the same analysis, just a little bit different names. This does not always mean the price. The price is always set by the demand curve, depending on the firm. But in every type of firm, MC equals MR will get you your quantity, your optimal output quantity, your unregulated quantity. So how do taxes affect this? Well, let's first look at lump sum. If there's a lump sum tax, it's essentially a change to your fixed inputs, your fixed cost. So if there's a lump sum tax, it's an increase in your fixed cost, your ATC will increase. If there is a lump sum lowering of your taxes, or if there is a lump sum subsidy, your ATC will shift downwards since your fixed cost will decrease. Now, we don't really graph fixed cost a whole lot, but your average fixed cost would be the distance between your ATC and your AVC. If there is a per unit tax, and so now we're taxing per unit per output. So now this changes our marginal cost and our AVC and our ATC. A tax will shift them all upwards if you increase the tax. If you decrease the tax or increase your subsidy, then you'd see them all fall. This changes output. Lump sum doesn't. Because remember, output is set by MC equals MR. Lump sum only changed the ATC. That didn't change output. Per unit is the only one that changes output because it shifts that MC curve. Make sure if they ask you about a per unit or a lump sum tax, you make reference to the MC equals MR quantity and if it changed. Now let's take these different revenue and cost curves and apply them to market structures. First one is perfect competition. So in perfect competition, this is when you have lots of firms, crazy amounts of firms, and it's very easy to enter or exit the market, and every product is identical. So you're extremely replaceable as a firm. So in this case, we have side-by-side graphs. We have the industry or market graph on the left-hand side. That's a basic supply and demand graph. You have your equilibrium price, you have your equilibrium quantity. That equilibrium price carries over to our firm. On our firm graph, and yes, you have to actually make sure that you demonstrate that the price in the industry is equal to the price in the firm. That price carries over to what we'll term the Mr. Darp line. The marginal revenue equals demand equals average revenue equals price. So that is the full Mr. Darp curve. It is perfectly elastic because they can't change the price. It's set by the market. If they tried to increase the price, nobody will purchase the product. If they tried to decrease the price, they would just be losing money, especially in the long run. You'll see why in the long run in a second. So this is a short run graph because this firm is earning profits. You know it's earning profits because at the MC equals MR quantity, which is the optimal output quantity, the average total cost is less than your average revenue. Your average revenue is on your Mr. Darp curve. So the Mr. Darp curve is in red. MC equals MR is set by the point A. So that's our quantity. In order to find your profit per unit, it's the difference between your average revenue and your average total cost. So those two. To find your total profit, it's the area of the rectangle formed by the difference between your average revenue, your average cost, the quantity, the y-axis, and your Mr. Darp curve. If you have a loss, your ATC will be above equilibrium. So if I draw it up here, now the firm is earning a loss. And once again, you find the loss box by the quantity to the ATC to the y-axis. That would be the loss box. Now that is all short run. In the long run, firms will enter or exit the market. Remember, in the short run, firms can't enter or exit the market. They can choose to shut down, but they can't enter or exit the market. So in the long run, if firms are continually losing money, so let's say supply was originally here. If supply was originally there, then we had a Mr. Darp curve down here. And our MC equals MR was here. This firm is obviously losing money since ATC is much above it. So in the long run, what occurs is firms will exit the industry. They will sell off their fixed inputs. Supply will decrease, which increases equilibrium price. It goes from here to here, increases equilibrium price until you get to long run equilibrium where the firm is earning a normal profit, where ATC is equal to the price. Now, a normal profit is a good thing because their accounting profit will still be positive. Remember, accounting profit is always greater than economic profit, which is represented on our cost curves. Now, I mentioned the idea of a short-run production decision. If your firm is losing money, you might still produce in the short run. And that's because it might cost you more money to shut down because you still have to pay those fixed costs. So the shutdown rule is when you can't cover or you can't pay for, is a better phrasing. The AP test doesn't accept the word cover. If you can't pay for your total variable costs, then you need to shut down. So the way you find this is total revenue is less than your total variable costs, or on the graph, which is much easier to see, your price is less than your AVC. Remember, fixed costs still exist if you shut down in the short run, and that's why this occurs. Our second type of market structure is the monopoly. In a monopoly, there is one firm that produces the product, and the product has no close substitutes, and it's very difficult for other firms to enter or exit this market. So that's why there's only one firm there. In this case, since the firm is the market, demand is downward sloping. Marginal revenue has to be downward sloping and separated out from demand because in order to sell more of this good, the firm must decrease the price. So that is the general setup. Why this graph looks this way. You find optimal output by the same way you found it in perfect competition. MC equals MR gets you your quantity. So MC equals MR gets your quantity. Your price is set on the demand curve, as I said before. Now, for perfect competition, the demand curve was the marginal revenue curve. So that's why MC equals MR also gave you your price. For monopoly, it doesn't, because the demand curve and the marginal revenue curve are separated. So price is set by the demand curve, the quantity on the demand curve gets you your price. This firm is operating at a profit because your ATC is less than your AR. Your AR is on your demand curve. you could really add equals average revenue equals price to the demand curve. And what you see, how you find your profit box is the same way you found it in perfect competition. Price to the ATC to the y-axis. Box formed by there is your profit. To find your consumer surplus, once again, you find it the same way we found it before. It's the price consumers pay at the quantity, demand curve, y-axis. Consumer surplus. Producer surplus in this case is the profit. If you're wondering why is it shaped that way, isn't there something else going on? Yes, there are inefficiencies represented by deadweight loss. Deadweight loss you find in the same exact way that we found it before. The supply curve, which is our marginal cost curve, demand curve, and the quantity. So this area that I'm coloring in red is the deadweight loss. That area is all deadweight loss. Now, what do you do with a monopoly? Well, you could regulate it. So you either break it up, have the government run it, or regulate it in many cases. So for a natural monopoly, one that has to exist due to economies of scale, high startup costs, in other words, you want to regulate a monopoly. So if it's unregulated, you see the monopoly price right here, set by MC equals MR. Gets your quantity, price set by the demand curve here. Now this is a higher price than what our socially optimal is. Socially optimal is the perfectly competitive outcome. It is allocatively efficient. That is set by our MC equals demand. So PR right there is our socially optimum, perfectly competitive outcome. So what you're seeing here is a monopoly produces less than socially optimal at a higher price. So a basic problem of monopoly is it produces too little at too high of a price. Also, not to be confused, yes, MC still intersects ATC at ATC's lowest point. It's just the shape of this graph and where it was cut off at that you didn't see that. Now, there is one other regulation point, and that's the fair return price or the break-even price. This is where the firm is earning a normal profit. That's where the ATC meets the demand curve, so PF right there. So that is the fair return price. So there are two problems essentially. There's a problem with each the fair return and the socially optimum. The problem with the fair return price is that there is still deadweight loss. You can see it by the quantity, the demand curve, and the supply curve. That area is the deadweight loss still remaining from this fair return price. The problem with the socially optimum price is when you're there, now the ATC is greater than your average revenue. So now the firm is earning losses. So in order for this to occur, the firm must get a subsidy. Otherwise, it wouldn't produce anymore. Last thing you have to know with monopolies is the idea of price discrimination. This is when firms will try to charge individuals their maximum price that they are willing to pay for the good. And the goal is to capture the entire consumer and producer surplus, turn it all into profit. So on the left, you see just a single price monopolist where they charge one price for the good and that's it. So they have a decent profit, but they could make more if they charge everybody their maximum. If they're able to do that, they capture that consumer surplus that we drew on the original graph. You see it on the one on the left, represented by here the quantity, the y-axis, demand curve, consumer surplus is there. That all becomes profit. You might be wondering, why didn't they go all the way to the ATC in this one on the right? It's because socially, they don't want to go any further. Society, consumers don't really need that much. So it would lose the money. And in the other graph, if the ATC is greater than the MC, if the break-even price is a higher price than a socially optimum price, they will stop at the ATC. So it's really whichever one they hit first. Our last two are oligopoly and monopolistic competition. Oligopoly doesn't have a graph that you have to know associated with it. Instead, we use game theory. So you have a payoff matrix. You have two firms. Here we've got the very creative labels yellow and white. They both have two strategies, low and high. And you have the payoffs here. On the AP test, you're likely going to see those payoffs listed directly next to each other, separated by a comma. The first one is most likely going to be associated with the firm on the left. The second one is going to be most likely associated with the firm on top, but it should be specifically spelled out for you in the question itself. Now, the way to analyze this, if you just sort of have to think logically, the idea, if yellow chooses a low price, we are looking at this row. If yellow chooses a high price, we are looking at this row. If white chooses a low price, we are looking at this row, or column. And if white chooses a high price, we're looking at this column. And then you just figure out the combinations. So if what yellow chooses low, white chooses low, then yellow gets 120, white gets 120. If yellow chooses high and white chooses low, then yellow gets 160 and white gets 50. So that walks you through how to look at it. Now, to figure out dominant strategy, you have to figure out what the firm will be wanting to do regardless of what the other firm does, because in the end, the firms don't care about each other. They know all the information in the payoff matrix, but they don't care about each other. They only care about themselves. So if we look at yellow's strategy, if they go low when white goes low, they make 120. Would they be better off if they switched? Yes, they would. If yellow switched, they can make 160. So low is not the dominant strategy. So is high the dominant strategy? Well, we already determined that if white chooses low, yellow should choose high. But to be a dominant strategy, yellow should choose high regardless of what white chooses. So if white chooses high, is it still better for yellow to choose high as well? Well, in this case, they'd make $100 if they do that. If they switch to low, they'd make 50. So yes, high is the dominant strategy. I'll spare you going through whites because whites has exactly mirrored payoffs here. High is the dominant strategy for white. Now, there won't always be a dominant strategy for um, each of these firms. In many cases, they might give you one firm has a dominant strategy, the other firm doesn't. So make sure you pay close attention to that. And they might ask you about Nash equilibrium. Nash equilibrium is now analyzing the payoffs when uh, both of the firms have made a choice. It will always exist as a shortcut where you have an intersection of dominant strategies. So when yellow chooses high and white chooses high, we are in this payoff square. That will always be a Nash equilibrium if you have two dominant strategies. And the way you analyze the payoff square is essentially, are they better off switching? So is yellow better off switching when it makes $100 choosing high? Well, if it switched, it would make 50. So no, it's not better off switching. Uh, is white better off switching? Well, if it sticks with high, it gets 100. If it switches, it gets 50. It's not better off switching. Therefore, this is a Nash equilibrium. This is the only Nash equilibrium in this payoff matrix, but you do have to actually take a look at every single payoff box because there might be multiple Nash equilibria. So pay close attention to that. The last thing they might ask you to do with this is to change the payoff matrix. And that's much easier than it probably sounds. All you have to do is add or subtract whatever they ask you to do for whatever payoffs they tell you. So if for some reason the low price was meant to be incentivized here, so the government says they will give $20 to anybody who sets a low price, all you have to do is add $20 to each of the low price payoffs. So if white chooses low, it now no longer makes 120, it makes 140. And if they in this one they'd no longer make 50, they'd make 70. They would no longer make 120, they'd make 140, and they would make 70 here. And that's all you have to do. And then it might ask you to reanalyze based off of those changes. For monopolistic competition, one more note on oligopoly. Oligopoly is when you have a low number of firms So usually in AP Econ, we only deal with two, but it could go up to maybe six or something like that. There's no exact number, but a small amount of firms that control a lot of the market, and products are similar in their high barriers to entry. For monopolistic competition, this is when you have lots of firms, not quite as many as perfect competition, but a lot. Um, and they all have similar but definitely differentiated products. And it's fairly easy to enter or exit the market. Best example of this is local restaurants, not chains, local. So think like your local pizza joint. When you have a local pizza place, they're all basically the same, but you definitely can tell the difference from one to the other. So what this looks like is essentially mini monopolies. They all have their own individual monopoly over their product because you can tell the difference. So demand is still downward sloping, marginal revenue is still separated out and downward sloping, swooshing MC, U-shaped ATC. You can have short run profits or losses the same way you have them in a monopoly. Analysis, all completely the same. However, in the long run, if firms are incurring profits or losses, firms can enter or exit. So if there are profits, firms will enter. And as firms enter, they will take away demand from the firm. If firms are incurring losses, they will leave the market in the long run. They will sell off their fixed inputs, and demand for the individual firms that remain will increase. What this looks like in the long run is a demand curve that is tangent to the ATC at the optimum output. Um, so they will earn a normal profit in the long run. Last thing you have to know about monopolistic competition is that advertising is extremely important for them because it creates a more inelastic demand curve, which will increase revenues. Uh, Unit 7 has to do with factor markets. So now we're flipping everything that we knew before. So everything that applied to demand now applies to supply. Everything that applies to supply now applies to demand. And that's because households are now supplying the factors of production, which are land, labor, capital, and entrepreneurship. Meanwhile, the firms are now demanding. They're the ones purchasing it. So when we talk about factor markets and what makes up supply and demand, demand itself is derived from the products it produces. So the factors of production, when the demand for the product has increased, that increases the price of the product, which increases the demand for the factor that produces that product. So if you are an auto worker and the demand for cars has increased, the price for cars has increased, which increases the demand for your job. Demand also changes through shifts in changes of your marginal product. If you are able to produce more, you are going to be more in demand in terms of your labor. Supply shifts are based on perceived trends in wage, tastes, things like that. So if you know that um, a job in nursing is going to be kind of easy to find and high paying, then you're going to go into nursing. That increases the supply of nurses. So things like that. That should be pretty much spelled out if it's in the question. It's important to remember in this the idea of diminishing marginal product. So this is the idea that as you add more of a variable input, it has to share in the same amount of fixed input. So you have one machine and you have three people who have to work on it. Once you have the fourth person in, that fourth person is going to be less marginally productive than the previous three. The fifth person will be less marginally productive than the fourth. Um, that's the idea of diminishing marginal product. Now, you could have increase in marginal product if you have specialization going on. So that will occur at low output quantities, as you have, if you can imagine a job, an assembly line where one person was doing everything. As you add people to that line, you're then going to increase the efficiency as people become specialized. But once you get to a certain point, as you add people, they will be more productive marginally, but less marginally productive than the ones before them. So that's the idea of increasing versus diminishing marginal product. So what does this look like when we graph it out? We have two types of graphs we have to know: perfectly competitive and imperfectly competitive, or monopsonies. So for perfectly competitive, we once again have side-by-side graphs. The price in this case is the wage, so you might see it labeled as either way of that. The quantity is still quantity, but now it's quantity of labor or quantity of capital, whatever your input is. You still have an upward sloping supply, downward sloping demand, equilibrium wage, and quantity of labor set by the intersection of supply and demand. The wage in the market sets the wage in the firm. So the firm, you have a horizontal or perfectly elastic supply curve. That's the marginal revenue cost or the marginal factor cost. So that is going to be perfectly elastic in this case. Supply, marginal factor cost. I prefer marginal factor cost to not confuse MR with marginal revenue. The downward sloping curve is also known as the marginal revenue product or the demand curve. Marginal revenue product is good because it reminds you that marginal revenue multiplied by the marginal product gets you your demand curve. And that explains why the demand curve shifts. If the marginal revenue increases, so the price of the product increases, then demand shifts. If the marginal product changes, then the demand shifts as well. So that's an easy way to understand that one. Monopsony. For a monopsony, now it's a single firm that purchases all of the input. So a single firm that purchases all the input. Now you have a downward sloping marginal revenue product curve, just like you had before, but you have a separated out and upward sloping supply curve and marginal factor cost curve. So the marginal factor cost is the one above it. Supply curve is the one below in blue. You hire where marginal factor cost equals your marginal revenue product. That gets you your quantity. The price you pay that labor or the wage is set by the supply curve. So marginal cost intersecting with marginal revenue product gets you your quantity of 3, and the price is paid on the supply curve at that quantity. Now this gets us to an interesting point where in a monopsony, you can increase the price. You can cause a minimum wage, like let's say here at 40 pounds, and increase the quantity of labor hired. You could do that for a monopsony. For perfect competition, you notice your MRP equals MFC quantity here. If you put in a minimum wage there, you now have in the market a higher quantity supplied than quantity demanded. And in the firm, it plays out the exact same way. Your supply curve has now risen, and your MRP equals MFC is at a lower quantity. So if it asks you about minimum wages effects on labor markets, it should specify perfectly competitive, which reduces the amount of workers hired, or a monopsony or imperfect competition, which could, at least up to a certain point, increase the amount of workers hired. From there, we take a look at input mixes. There are 2 types of input mixes you have to know: the cost minimization and profit maximization. Cost minimization comes up a little bit less than profit maximization. And this is just sort of how do you become more and more efficient in terms of your costs? How do you keep costs low? To get to the minimum of your ATC, what you're really looking at is your marginal product divided by the wage or your marginal factor cost of whatever that input is that equal for all of the inputs? So MP sub L is marginal product of labor divided by the wage you pay that labor. Is that equal to your marginal MP sub K, which is your marginal product of capital, divided by the rental rate of that capital? So how much you pay that capital, the wage of the capital, if you will. If they're equal, then you are cost minimized. If you're profit maximizing, this is really just MRP equals MFC, since MRP divided by the wage, which is the MFC, equals the marginal product, marginal revenue, it should say marginal revenue product of capital divided by the rental rate of the capital, which is the marginal factor cost of the capital. If that equals 1, then you profit maximized. That's just MRP equals MFC. Our last unit is market failure and government intervention. This deals mainly with externalities. So we have positive and negative externalities. A positive externality denoted by 2 benefit curves. You have a social benefit curve, or MSB, above your marginal private benefit curve. So in this case, you produce too little for what is beneficial for society. There are external benefits that aren't being fully explored. So what you want to do is bring your marginal private benefit to be in line with your marginal social benefit. So how do you do that? You provide a Péjovian subsidy, which is a per unit subsidy designed to shift your private benefit to be in line with your social benefit, eliminating the deadweight loss that you see here. Negative externalities are the opposite. It's denoted by two cost curves. You have a social cost curve above our private cost curve. In this case, our private equilibrium is going to be at a greater quantity than our social equilibrium. So what we want to do is reduce the amount that's produced. So how do we do this? We have a Péjovian subsidy, which is a per unit, a Péjovian tax, which is a per unit tax designed to shift our marginal private cost to be in line with our marginal social cost. Uh, you do have to keep in mind different types of goods, since the markets that we talked about previously really only affected private goods efficiently. Any other type of good is not provided in an efficient manner by free markets. So, what do we mean by the types of goods that we've been talking about before? What are private goods? These are rival in consumption. In other words, me consuming a cookie means that you can't eat that cookie too. And they are excludable. I purchased that cookie, so the business I bought it from could exclude me from purchasing it if could exclude me from consuming it if I didn't pay for it. Uh, the most common one that you're going to see on the AP test is public goods. This is things that are the complete opposite of private goods. They are non-rival in consumption, so everybody can uh, consume it at the same time, and they are non-excludable because somebody doesn't pay for it, you can't exclude them. Best example of this is going to be national defense. Uh, the other two that might show up are artificially scarce goods. These are excludable but non-rival, and common resources, which are non-excludable but rival in consumption. Um, Now, the reason why uh, these are types of market failures is because that charity or government must step in to provide the socially optimal level, or they must regulate because something will occur that doesn't actually benefit everybody. So, for common resources, you can have the free rider problem, you can have the tragedy of the commons. For artificially scarce goods, the marginal cost is actually going to be equal to zero, so you're never going to be truly efficient there. That one probably doesn't need charity or government, but you might need some regulation there for not overpaying. And public goods, this is just something that because it is non-excludable, it is very very difficult uh, to get people to pay for. The last thing you have to know has to do with tariffs and world trade and what they look like when you examine a domestic market. So first, we have a domestic market. See here, basic supply and demand curve. Uh, and once again, it's important to remember that this is a domestic market. Equilibrium is set by supply and demand. When you start trading with the world, they might have a world price that is lower than yours. In other words, their domestic supply and demand is at a lower price than ours. So when we go to trade with them, they are going to be selling it to us and we will be importing it at a lower price. Obviously, our domestic suppliers cannot keep up with this, but our domestic demand is greater. So the way this looks is essentially it'll look like a price ceiling. It should be below our equilibrium price, as you see here, PW. Uh, our quantity imported is going to be the difference between our quantity demanded and our quantity supplied domestically. So here you see Q1 is our quantity supplied, Q2 is our quantity demanded. The difference between those is how much we import. And we then use this to analyze our surpluses. Our consumer surplus grew like crazy. Uh, So you see the quantity consumed, the price consumers pay, the y-axis, the demand curve, all of that area in purple is consumer surplus. The producer surplus, however, shrank. So you see the price producers received at the quantity they sold, the supply curve, the y-axis, that area that I just outlined, that's the producer surplus. That shrank a lot. However, total surplus, you see, clearly grew since total surplus used to be the quantity, the supply curve, the y-axis, and the demand curve, we definitely have a larger area. So this is why international trade is beneficial, economically speaking, as you have more total surplus. Now, when you put a tariff on the good, what you're looking at doing is increasing producer surplus domestically to make your domestic producers a little bit better off, try to make them more competitive in the world market. So the way you do this is you essentially add the quantity of the tariff, add the amount of the tariff to the world price. So it shifts the world price upward by the amount of the tariff. You see that done here. As a result, you see our quantity supplied domestically increases from Q1 to Q3, and our quantity demanded domestically decreases from Q2 to Q4. That means we import less. How does this work out for efficiency in our different surpluses? Well, you see that our consumer surplus decreased. So the price consumers, the quantity imported or purchased by consumers, the price they pay, the y-axis, the demand curve, that purple area, the producer surplus domestically increased. So this is the quantity they sold, the supply curve, the y-axis, and the price they received. So you see producer surplus definitely increased, but there is a loss of total surplus. And where does that go? It goes to deadweight loss and tax revenue, or tariff revenue, if you will. The tax revenue is the quantity imported multiplied by the amount of the tariff, or this area in green, and the other areas, those two yellow triangles, that's going to be deadweight loss. So that is just a brief overview of everything AP microeconomics. If you have any questions, feel free to send me an email.